Geometry, Chapter 8, and I want to look at how to solve a tangent ratio when the angle is what is the missing variable. We talked about how to solve for either the opposite side if the adjacent side is missing, or how to solve for the adjacent when the opposite's missing. And we also talked about how to solve for an angle when the angle is missing, but I want to review that for you. Now, if we are to solve for the angle measure, meaning the angle measure is what is missing, or that's what we're asked to determine, we are going to go ahead and begin by writing our tangent ratio, but then that creates an algebraic problem. So for example, in this problem here, we have x, which is the unknown angle, and it's the variable. We know the opposite and adjacent, so I would write my ratio, the tangent of x is equal to the opposite over the adjacent. And as we talked about, the tangent of x is one number, and I really should think of this as having a parenthesis around it so I can't break it. There's no way to solve for x, and we're not solved for, and we don't have our exact answer until x is by itself, or the variable. So there's no algebraic way to do this because I can't just split a word from, the letter x, because they go together. So we talked about what we have to do is apply the inverse tangent function. And again, we'll talk more about that as we go deeper into trigonometry next year in advanced algebra. So what I need to do then here is to apply the inverse tangent function, and this, you remember, is using the word tangent and then indicating with a -1. This represents the inverse tangent then of 1/2. So this is my equation solved for x. X is equal to the inverse tangent of 1/2, and this would be my exact answer. Now to calculate this on my calculator, you'll notice if you're using the TI-84 in the top leftish corner, not the very top, but the top of the keyboard, you'll notice a blue key that says second. If you enter in there or select that key and then select the tangent key, this inverse tangent will come up on your screen, and then you can enter in the ratio 1/2. When I do that, I'll get a tangent as x is equal to 26.5. Because I'm rounding to the nearest degree, I stop at the tenths place because that's the digit that I'll use to round to the whole degree, or this place here. So x would be about 27 degrees. So when the angle is the unknown measure, we use the inverse tangent function to solve for x and then to calculate our measure. Let me do one or two more real quickly so you see how that's done. In this example, again, the x is the angle measurement, which is unknown, but I do know the opposite and adjacent, so I'm going to use the tangent ratio. So the tangent of the angle, which here is x, or unknown, is equal to 7/11. And again, this cannot be split up except by using the inverse tangent rule, or the inverse tangent function, excuse me. So x is going to be equal to the inverse tangent function of 7/11. So this would be my exact answer. This is solved for x. X is by itself. Now I'm asked to round it to the nearest degree, so I would then calculate this by using the second key, tangent key, which brings up the inverse function screen, enter in 7/11 and calculate. That would give me 32.4. I'm rounding to the nearest degree, so I only need the tenths place. Because this tenths place is a 4, the 2 remains the same, so this is about a 32-degree angle. Let me do one more where I have something missing, something we talked about in class, but just to review. Again, the angle, or the variable I'm solving for, is the angle. I notice I have opposite, but I don't have adjacent. So in this case, in order to use the tangent ratio, I'm going to have to determine what this adjacent side is. Now remember, in a right triangle, whenever we're given two sides and I need a third length, Pythagorean theorem is going to be my most, let's see, it's going to be my best friend when it comes to this case. So I can go ahead and apply the Pythagorean theorem to figure out this missing side. So the Pythagorean theorem says that one leg squared, which here is 11, plus the other leg squared, which is the one I'm missing, I'm going to use that, is equal to the hypotenuse, which in this case is the square root of 170 squared. And then I'll go ahead and calculate this. So b squared is going to be equal to then 100, the square root of 170 squared minus 11 squared. And then b is going to be equal to then the square root of 170 squared minus 11 squared. Now I'm going to go ahead and do this without a calculator because this calculation is fairly easy, but this is the square root then. The square root of 170 times itself is going to be 170, and then 11 squared is 121. So this is going to be the square root of 49, which ends up being 7. So my adjacent side here is going to end up being 7, which I calculated using the Pythagorean theorem. Now that I have the adjacent side, I can use my tangent ratio. So the tangent of the angle, which again is unknown, is equal to the opposite side 11 over the adjacent side 7, which I calculated with the Pythagorean theorem. Solving for x, I need to use the inverse tangent function, so this would be the inverse tangent of 11 over 7. This again would be my exact answer. I'm solved for x. I would then use my calculator to get the estimated answer. I'm rounding to the nearest degree, so I only go to tenths place, which tells me then the 7 needs to round up, so this is about a 58-degree angle. So when you're solving or using the tangent ratio to solve for an angle, and actually if you're using any trigonometric ratio and the angle is what's unknown, you're going to use the inverse function of that trigonometric ratio, in this case the inverse tangent ratio. No, the inverse tangent function.